Good day, everyone. I will discuss mathematics in our world. What is mathematics? Mathematics is the science of structure, order, and relation that is involved from elemental practices of counting, measuring, and describing the shape of objects. Also, mathematics is a tool to quantify, organize, and control our world, predict phenomena, and make life easier for us. Importance of mathematics. Math is good for the brain, promotes logical and analytical thinking. Math helps you with your finances. Math makes you a better cook. Every career uses math. Also, mathematics helps you when it comes to time management, help you understand the world better, and math is essential in a world of constant change. Who is father of mathematics? He is Archimedes. Patterns and numbers in nature in the world. Patterns in nature are visible regularities of form found in the natural world and can also be seen in the universe. Nature patterns are not just to be admired. They are vital clues to the rules that govern natural processes. Patterns defined as regular, repeated, recurring forms or designs, identify relationships, find logical connection to form generalizations and predictions. Types of pattern. 1. Symmetry, a sense of harmonious and beautiful proportion of balance or an object is invariant to any various transformation, reflection, rotation, or scaling. Bilateral symmetry and radial or rotational symmetry. 2. Fractals, a curve or geometric figure, each part of which has the same statistical character as the whole. A fractal is a never-ending pattern found in nature. The same shape is replicated in a process called self-similarity. For example, a tree grows by repetitive branching. The same kind of branching can be seen on lightning bolts in the vein in your body. Examine single fern or an aerial view of an entire river system and you'll see the fractal patterns. 3. Spirals, a logarithmic spiral or growth spiral in a self-similar spiral curve that often occurs in nature. It was first described by René Descartes and was later investigated by Jacob Bernoulli. Examples of spirals are pine cones, pineapples, and hurricanes. The reason why plants use a spiral form is that they are constantly trying to grow but stay secure. The snowflakes and the honeycomb. All snowflakes contain six-fold symmetry, which no two are the same. Order of rotation. A figure has a rotational symmetry of order n, n-fold rotational symmetry if 1 over n of a complete turn leaves the figure unchanged. Angle of rotation 360 degrees over n. End example. Another example, as you can see, there's hexagonal packing. Tiger stripe and hyena spot, pattern exhibited in the external appearances of animals. The tiger looks at hyena spot. Their seemingly random design are believed to be governed by mathematical equations. The sunflower. Looking at the sunflower, there is a definite pattern of clockwise and counterclockwise arc of spirals extending outward from the center of the flower. The snail shells. As the snails grow, their shells also expand proportionally. This process results in a refined spiral structure. It is called a triangular spiral. Flower petals. Flowers are easily considered as things of beauty. Flowers with 5 petals are said to be the most common. Number of petals are all Fibonacci numbers. Additional example is the world's population, which considered as pattern. Also, weather can identified as pattern too. Next, I will discuss the Fibonacci sequence. Fibonacci, also known as Leonardo Bonacci, Leonardo of Pisa, or Leonardo Bigolo Pisano, was an Italian mathematician from the Republic of Pisa, considered to the most talented Western mathematician of the Middle Ages. Origin of Fibonacci sequence. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. Example of growing population of rabbits. Problem. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month so that at the end of second month, a female can produce another pair of rabbits. Fibonacci sequence is an integer in the infinite sequence 1, 1, 2, 3, 5, 8, 13, and so on, of which the first 2 terms are 1 and each succeeding term in the sum of the 2 immediately preceding. Simple rule: add the last 2 to get the next. Example: how many pairs will be there in 1 year? 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So, 144 pairs will be there at the end of 1 year. Example of Fibonacci sequence in nature: Fibonacci spiral in sunflower and pine cones. The golden ratio is often denoted by the Greek letter. This is approximately equal to 1.618. The golden ratio can be expressed as the ratio between two numbers. A over B equals A plus B over A. Did you know that mathematics helps to organize patterns and regularities in the world? Mathematics for organization. A lot of events happen around us in a blink of an eye. Several children have been born, liters of water have been consumed, and thousands of comments, pictures in FB have been posted. For us to make sense available information, we need mathematical tools to help us make sound analysis and better decisions. Examples: a particular store can gather data on the shopping habits of its customer and make necessary adjustments to help drive sales. Scientists can plot bird migration routes to help conserve and endanger animals' population. Social media analysis can crunch all online posting using software to gauge the netizen sentiment on the particular issues or personalities. Also, mathematics helps predict the behavior of nature and phenomena in the world. Mathematics for prediction. It is sometimes said that history repeats itself. As much as we can use mathematical models using existing data to generate analysis and interpretation, we can also use them to make predictions. Applying the concept of probability, experts can calculate the chance of an event occurring. Examples: the weather is a prime example based on historical patterns. Meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us weather disturbances that can affect our activities for a week or month. Astronomers also use patterns to predict the occurrence of meteorites, shower, or eclipses. Though mathematics help control nature and occurrences in the world for our own ends. Mathematics for control. We have demonstrated by means of example around us that patterns are definitely present in the universe. There seems to be an underlying mathematical structure in the way that natural objects and phenomena behave. Examples: photographers could capture a single moment through a snapshot. Videographers could record events as they unfold. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe an object. Musicians could capture and reproduce sounds that they hear. Another example, in 1916, Albert Einstein hypothesized the existence of gravitational waves based on his theory of general relativity. This is when ripples are formed in the fabric of space-time due to large and violent cosmic events, very much like when pebbles are thrown on a stagnant pond. Similarly, mathematics has numerous applications in the world, making indispensable. Mathematics indispensable. How is it possible that mathematics, a product of human thought that is independent of experience, fits so excellently the objects of reality, according to Albert Einstein? It was highlighted how mathematics plays a huge role in underpinnings of our world. We have seen it in living creatures and natural phenomena. We have also looked at examples of how mathematical concepts could be applied. Whether you are on your way to becoming a doctor, an engineer, an accountant, a public servant, or a chef, a knowledge of mathematics will be helpful. At the most basic level, logical reasoning and critical thinking are crucial skills that needed in my endeavor. As such, the study of mathematics should be embraced. It paves the way for more educated decision and, in a way, bring us closer to understand the natural world. So now, the discussion is over. I'm Mika D. Halok, and thank you for watching.
The characteristics of mathematical language: precise, concise, and powerful. Precise mathematical language is able to make very fine distinctions or definitions among a set of mathematical symbols, unlike in ordinary speech, which is full of ambiguities and innuendos, hidden agendas, and unspoken cultural assumptions. Using this precise mathematical language is a strategy to build a shared understanding of key mathematics terms and symbols. Concise long expositions or sentences can be expressed briefly using the language of mathematics. Mathematical language and symbols cut short the lengthy statements and help the expression of ideas or things in the exact form. Mathematical language is free from verbosity and helps into the point, clear and exact expressions of facts. Powerful mathematical language is able to express complex thoughts with relative ease. Mathematical expressions versus mathematical sentences. First, a mathematical expression. A mathematical expression is the mathematical analog of an English noun. A correct arrangement of mathematical symbols used to represent a mathematical object of interest. It does not state a complete thought and does not make sense to ask if an expression is true or false. In mathematics areas, for example, algebras, the most common expression are numbers, sets, and functions. Now moving on to mathematical sentence. A mathematical sentence is the mathematical analog of an English sentence and is a correct arrangement of mathematical symbols that state a complete thought. Hence, it makes sense to ask if a sentence is true, false, sometimes true, or sometimes false. In this table, I'm going to show you an example to tell the difference of expression and sentence in mathematics. For expression, we have 20, 4 plus 3, 3x. Those are some examples and it does not make sense to ask if this is true or false. I'll give you another example but in English expression. Let's say Juan or sorsogon or ruler. On what I have said are nouns, but in math I gave you like a number 20, so it's like I said earlier, it does not give a complete thought. Moving on to sentence, we have 4 plus 9 equals 13, 7 plus 5 equals 12, 4 times 2 plus 7 equals 15. So it makes sense to ask if this is true or false. So I'm gonna give you another example, but in English sentence. Let's say the province of Sorsogon is a province in Bicol region, Philippines. So this is a sentence. In math, I give you 4 plus 9 equals 13. As long as it states a complete thought, it is safe to say that this is a sentence. Next, mathematical convention. A mathematical convention is a fact, name, notation, or usage which is generally agreed upon by mathematicians. For instance, the fact that one evaluates multiplication before addition in the expression 2 plus 3 times 4 is merely conventional. There is nothing inherently significant about order of operations. Mathematicians abide by conventions in order to allow other mathematicians to understand what they write without constantly having to redefine basic terms. So here are some mathematical conventions. Here we have number and quantities. Numbers are expressed in base 10 unless otherwise noted, using the 10 digits 0 through 9 and a period to the right of the ones digit or units digit for the decimal points. Also, in numbers that are 1000 or greater, commas are used to separate groups of 3 digits to the left of the decimal point. Example, we have 1 million and the other one, another 1 million but with commas. Here's some other conventions involving numbers. Here we have the word 1 billion, then into a numeric 1 billion, and it shows that it equals to 10 raised to 9. Another is the word dozen, and most of us knows that a dozen is equals to 12. Then we have pi. For those who don't know, it basically represents the ratio of the circumference of a circle to its diameter, which is shortly equals to 3.14. So moving on, when a positive number is to be rounded to a certain decimal place and the number is halfway between the two nearest possibilities, the number should be rounded to the greater possibility. For example, 23.5 rounded to the nearest integer is 24, and 123.985 is rounded to the nearest hundreds is 193.99. So the way you round up is simple. If the number next to it is 5, and above, then that number you add 1, so the other will become 0 or remove it. If it's below 5, then you don't add 1 to the other number. Example, 23.5 is going to be 24. But if it's 23.4, then it's going to be
it's 23.
Okay, next, we have mathematical expressions, symbols, and variables. When variables are given, their possible values are all real numbers unless otherwise restricted. It is common to restrict the possible values in various ways. Example, n is a non-zero integer. 1 lesser than x, lesser than 2. In this, x can be any number possible, but for now, the number should fit in based on the given. It shows that 1 is lesser than x, and x is lesser than 2. So it can be any number between 1.1 to 1. Moving on, standard mathematical symbols at the high school level are used. These include the standard symbols for an arithmetic operation of addition, subtraction, multiplication, and division. Multiplication is usually denoted by juxtaposition, often with parentheses. Example, 5y. This is an example of juxtaposition. It means two things being close together. So whatever that y may be, it will be multiplied by 5. Another one is 3 inside of a parenthesis and 4.5, which is also inside of a parenthesis. Since these two numbers are in separate parentheses, it means they are going to be multiplied. Next, another one is division is usually with horizontal fraction bar. Example, here we have 25 over 5. This actually states 25 divided by 5. Now moving on to 4 basic concepts: sets, functions, relations, and binary operations. First, we have set. A set is the representation of a collection of objects, distinct objects with one or more common properties. Grouping up the objects in a set is an act of distinguishing those objects from the member of another set. We can use the terms elements or members of a set instead of the term objects. Here we have some notations. First, we have set roster notation. If S is a set, the notation X and the symbol element, then X means that X is an element of S. The notation X and the symbol not an element, and then S means that X is not an element of S. A set may be specified using the set roster notation by writing all its elements between braces. For example, inside the brace we have 1, 2, and 3. This denotes the set whose elements are 1, 2, and 3. Next, set builder notation. Let S denote a set and let P, X, be a property that elements of S may or may not satisfy. Okay, now moving on to subsets. If A and B are sets, then A is called a subset of B, written A and the symbol subset and then B. If and only if every element of A is also an element of B. Symbolically, A subset of B means that for all elements of X, if X is an element of A, then X is an element of B. Next, we have a proper subset. Let A and B be sets. A is a proper subset of B, and if and only if every element of B is in B, but there is at least one element of B that is not in A. Moving on to relations and functions. Relations and functions are the set operations that help to trace the relationship between the elements of two or more distinct sets or between the elements of the same set. The relation is the subset of the Cartesian product, which contains only some of the ordered pair based on the relationships defined between the first and second elements. The relation is usually denoted by R. If every element of a set A is related with one and only one element of another set, then this kind of relation qualifies as a function. A function is a special case of relation where no two ordered pairs can have the same first element. So here we have the types of function. We have identity function, constant function, polynomial function, rational function, modulus function, signum function, and greatest integer function. Moving on to binary. Binary is the basic operations of mathematics, which is addition, subtraction, division, and multiplication, are performed on two operands. We take the set of numbers on which the binary operations are performed as X. The operation, addition, subtraction, division, multiplication, etc., can be generalized as a binary operation is performed on two elements, let's say A and B, from set X. The result of the operation on A and B is another element from the same set, X. So basically, a binary operation is simply a rule of combining two values to create a new value. Next, we have elementary logic. Connectives, quantifiers, negation, and variables. First, connective. A function, or the symbol representing a function which corresponds to English conjunctions such as and, or, not, etc. that takes one more or more truth values as input and returns a single truth value as output. So here is a table that shows the connective and its symbols. Moving on to quantifiers. Quantifiers are words that refers to quantities such as some or all. It tells for how many elements a given predicate is true. There are two types of quantifiers: universal quantifier and existential quantifier. I'm going to show you an example of a quantifier. So this is a quantifier right here. So let Px be a statement. X plus 1 and greater by x. Here we have P1. So x is equals to 1. 1 plus 1 greater than 1 equals to 2 greater than 1. Which is true, and the same with P2. It is just gonna continue to be true. So that is a quantifier. Moving on to negation. Sometimes in mathematics, it's important to determine what's the opposite of a given mathematical statement is. This is usually referred to as negating a statement. One thing to keep in mind is that if a statement is true, then its negation is false. And if a statement is false, then its negation is true. For example, now let's consider a statement involving some mathematics. Take the statement, if n is even, then n over 2 is an integer. For this statement to be false, we will need to find an even integer, n for which n over 2 was not an integer. So the opposite of this statement is the statement that n is even and n2 is not an integer. Moving on to variables. Variables is a symbol, usually a letter, standing in for an unknown numerical value in an equation. Commonly used variables include x and y, which are real number unknowns, z, which are complex number unknowns, t for time, r for radius, and s for arc length. Variables should be distinguished from coefficient fixed values that multiply powers of variables in polynomials and algebraic equations. For example, in this equation, ax plus bx plus c equals to 0, x is the variable a, and a, b, and c are coefficients whose value must be specified to solve the equation. In translating word problems into algebraic equation, quantities to be determined can be represented by variables. Next, we have formality. In mathematics, a formal language is normally defined by an alphabet and formation rules. The alphabet of a formal language is a set of symbols on which this language is built. Some of the symbols in an alphabet may have a special meaning. The formation rules specify which strings of symbols count as well-informed. The well-formed strings of symbols are also called words, expressions, formulas, or terms. The formation rules are usually recursive. Some rules postulate that such and such expressions belong to the language in question. Some other rules establish how to build well-formed expressions from other expressions belonging to the language. It is assumed that nothing else is a well-formed expression. So here, for example, the language of propositional calculus could be defined as follows. The alphabet of this language is comprised of English letters with optional indexes and the following special symbols. So here are the symbols of not, and, or, and implies, and grouping. The formation rules are then that are very English letters, and every letter with an index is a formula. And if A and B are formulas, then so are not A and B, A or B, or A that implies to B, and A that has a grouping symbol.
Problem-solving strategies. Number 1. Guess and check. A classic technique, it requires a low level of efforts because you can always guess an answer to a question. Ito yung tinatawag na trial and error, and nahuhulaan natin ang mga answer. Or, i-check natin yung kung applicable ba siya. Number 2 is act it out. Performing a specific task to solve a problem, it has a very limited application like grouping a class. So, depende dun sa problem kung pwede natin bigyan ng action, kung masosolve ba siya by a simple doing of action. Next is draw. Draw, it is uses pictures, Venn diagram, sketches, maps, and other representation to solve mathematical problem. So, minsan sapat na yung mga drawing lamang or sketch kung and lang yun ang hinihingi sa problem. Example, allocation. So, pwede na tayo maglagay ng maps. Mayroon tayo sa iba't ibang application for giving maps. Lists and tables. Helps discover hidden hints toward the solution of some problems, and also an efficient way to find number pattern like a Fibonacci sequence. So, pag-list natin ang mga items, makikita natin kung ano ang mga missing, kung meron bang given patterns, and sa pag-rate ng table makikita natin yung relationship between objects na ginagamit natin. Problem solving strategies example. Micah bought books and CDs as a gift. Altogether, she bought 12 gifts and spent 840 pesos. The book cost 60 pesos each and the CDs 90 pesos each. How many each gift did she buy? How to understand the problem? 800 pesos will be spent to buy 12 gifts. The gift should be books and CDs. The cost is 60 pesos each and 90 pesos each, respectively. Guess number 1. 6 books and 6 CDs. So, para makuha natin yung yung answer is 6 plus 6 equals 12. So, check natin. 6 times 60 equals 360. 6 times 90 is equals to 540. Final answer is 900. So, mali po. So, guess number 2. 7 books and 5 CDs. Check natin. 7 times 60 is equals to 420. And the CDs is 5 times 90 is equals to 540. The answer is 670. So, try to find ways pa rin. Mali pa rin. So, guess number 3. 8 books and 4 CDs. Check natin. 8 times 60 is equals to 840 times the 4 CDs. 4 times 90 is equals to 360. Final answer is 840. The answer is the guess number 3. Micah bought 8 books and 4 CDs. Mathematical problem involving pattern. Many mathematical problem has a predictable pattern. Ito ang problem ng math na meron ng involves na pattern kung may pipredict ba siya because of that pattern. A pattern is a regular systematic presentation and may be numerical, visual, or sequential. Dahil sa pagiging regular and systematic nito, so makikita natin, so it can be predicted. Example, what is the total sum of the first 100 number? So dito, given that problems, ano ba ang hinanap dito? So ang hinanap natin dito is the sum. And ano yung mga given, yung first 100 numbers, ano-ano ang mga 101 numbers na yan. So, one of the possible solution 1 to 3 and so on, 49 to 15 so on, and 99, 98, 99, 100. Now, ano yung makukuhang pattern? So, pwede natin i-pair ang una at ang dulo, which is 1 and 100. And ang sum nila is 101. Pangalawa, 2 plus 99 is equals to 101. 3 plus 98 is equals to 101. 49 plus 52 is equals to 101. 50 plus 51 is equals to 101. There are 50 pairs of sum equals to 101. Therefore, 50 pairs times sum of 101 is equals to 5,050. Reactional problem using mathematics. This is the type of mathematics is being used for leisure or recreational activity. These are called the mathematical games. First is the Rubik cubes. Second is the tangram puzzle. And the last one is Sudoku, or what we call Sudoku game.
Problem solving and reasoning. There are two types of reasoning, inductive and deductive reasoning. Inductive reasoning, from specific information to general conclusion. It is making generalizations out of particular instances. Example 1. First premise, my math teacher is good looking. Second premise, my last math teacher was also good looking. Conclusion, therefore, all math teachers are good looking. Ang first statement natin ay consider as a specific information. Our subject is math teacher and our characteristic is good looking. So sa second premise naman ay naulit yung characteristic, which is yung good looking, pero sa ibang subject naman as last math teacher. So sa inductive reasoning, yun yung mga example ng specific information natin. Since naulit yung specific information natin, nagko-conclude tayo na yung susunod pang instances ay ganun din yung kakalabasan ng characteristic, which is all math teachers are good looking. Gine-generalize natin na yung particular instances na yun ng characteristic ay mauulit lang din ulit dun sa iba pang same subject ng ating sentence, which is yung math teachers. Example 2. First premise, I am a great swimmer. Second premise, my family live near the sea. Conclusion, therefore, my son is also a great swimmer. Dito naman, yung first premise natin ay mayroong characteristic na great swimmer. At ang subject natin ay ang tinutukoy na magaling na swimmer. So, yun yung ating specific information. So, sa second premise naman, my family live near the sea. So, ito yung reason kung bakit yung subject natin, which is yung tinutukoy ay magaling na swimmer. So, dun sa conclusion naman, we have another subject but the same characteristic. Included naman dun sa collection ng mga subject, which is yung my family live near the sea. So, ibig sabihin, kino-conclude dito na yung iba pang miyembro ng pamilya ay magaling din na swimmer dahil sa malapit sila sa dagat. Yun. So, ang inductive reasoning ay useful kung ito ay ginagamit sa mga statistical survey. Dahil sa statistical survey, gumagamit tayo ng iba pang testing o statistical test kung valid ba yung conclusion natin. So, pangalawa ay deductive reasoning. from general information to a specific conclusion. So, kabaliktaran ng inductive reasoning. Concluding a specific fact out of a general information. So, ito yung pagko-conclude ng isang bagay out of general information. So, kung meron tayong characteristic ng general population, so ma-inherit natin siya ng specific fact example. Yun. So, kabaliktaran ng inductive reasoning. Example number 1. First premise, all number ending in 0 or 5 are divisible by 5. Second premise, the number 35 ends with 5. Conclusion, therefore, 35 is divisible by 5. Dito, ang general information natin sa first premise is all number ending in 0 or 5 are divisible by 5. And meron tayong specific instance na yung 35 sa second premise nag-end ng 5. Then, as a conclusion na inherit ng 35 yung characteristic ng all number ending 0 or 5 which is divisible by 5. Example number 2. First premise, all squares are rectangle. Second premise, all rectangles have 4 sides. Conclusion, therefore, all square have 4 sides. Okay, dito naman, given sa general information is all squares are rectangles. Dito, hindi natin sigurado kung tama ba ang sinabi. Papansin natin sa second premise, all rectangles have 4 sides, which is another general information, and it is a fact. So sa conclusion natin, pwede natin i-include that all squares have 4 sides, since ang squares are rectangle at ang lahat ng rectangle are may 4 sides. Intuition, the ability to understand something instinctively without the need for conscious reasoning. So, ito yung in time na may na-encounter tayong problem, alam agad natin kung ano yung gagawin because of instinct yung gumagana sa atin. This is achieved by having previous knowledge about the topic. So, gagana lang yung institution kung may alam ka na previous knowledge about sa topic na kinakaharap mo. For example, magpapalipad ng eroplano. So, paano magpapalipad ng eroplano kung hindi mo pa na-try o hindi mo pa pinag-aaralan? So, you don't have previous knowledge about that. Mathematical proof, an argument which convince other people that something is true but there must be proof. Yun. Ang mathematical proof ay mga argument o statement na nag-convince sa iba na yung solution or statement is truth, but you must show proof. Yun. It can be shown by writing solution or stating the fact using any of the types of reasoning. Certainty, the conclusion or outcome beyond doubt. So ito yung assure na yung statement ay certainly true based from the argument as proof na yung statement or conclusion is verified to be undoubtedly true. So dako naman tayo sa Puglia's first step in problem solving. So this is developed by George Puglia, father of modern problem solving. Yun, first step, institution. Second step, thinking time. Third step, insight. And fourth step is verification. Preparation. understand the problem. So, yun. Kailangan muna natin intindihin yung problem bago tayo magbigay ng solution. What is being asked? So, we need to identify the unknown o yung kung ano man yung answer na kailangan nating hanapin. Gathering the given information in the problem. So, kung ano yung mga giving fact or information inside the problem. Isa-isahin natin ilista or kunin natin para magamit natin later on sa ating mga solution. Number 2, thinking time. Device plan. So, dito mag-iisip tayo ng iba't ibang plano kung paano mo i-solve ang problem. Create possible solutions using simple problem solving strategies. Yun. So, there's problem solving strategy. Number 1, guess and check, act it out, draw, listen tables, and so etc. Number 3, insight, carry out the plan. So, yun yung kung ano man yung napili mo solving strategy, so yun yung gagamitin mo. Keep on trying until one of your plan or approaches work for the problem. Verification, look back. So, ito ay yung pag-check kung tama ba yung solution mo or kung applicable ba sumunod ba sa mga principle yung mga solution. Did you answer the question? Yun, yung mga guide question. Did you double check? Yes, always double check if the solution is correct. It is applicable to similar problem.
Rochelle G. Dialca, Midterm Project, Beth ELX 1C. I will discuss about data management. Data management. Data management or statistics. The science of collecting, organizing, presenting, analyzing, and interpreting numerical data. Statistics involve sampling method. It covers how data will be collected. Data management has different types. Descriptive statistics is concerned with collecting, organizing, presenting, and analyzing numerical data. Inferential statistics, also called statistical inference or inductive statistics, is concerned with analyzing organized data leading to prediction or inferences. The characteristics that is being studied are variables. It varies across individuals or objects. Two types of variables, qualitative and quantitative. Under the quantitative, there is discrete and continuous variable. Discrete variables that can be counted exactly, unlike continuous variable that used measurement just to determine the characteristics of the example. Qualitative variables represent difference in quality, character, or kind but not in amount. Example, sex, birthplace, or geographic locations, religious preference. 2. Quantitative variables, numerical in nature and can be ordered or ranked. Example, weight, height, age, test scores, speed, and body temperatures, grades, etc. It can be categorized as discrete or discrete variables, variable whose values can be counted using integral values. Example, number of students in classroom, number of computer functioning, number of mathematics subject, and numbers of calls received. Continuous variables, variable that can assume any numerical value over an interval or intervals. It can yield decimals or fractions. Example, height, weight, temperature, time. Dependent and independent variable. Dependent, the variable whose value is being predicted. Independent, the predictor. Data, a collection of observations on one or more variables. Factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. Scales of measurement, nominal or categorical data, use numbers for the purpose of identifying membership in a group or category. Example, electric consumption. 2. Ordinal data, cannot ranking or inequalities. Example, grades. 3. Interval data, does not include greater than and less than relationship, but also has a limit of measurement that permits us to describe how much more or less one object possesses than another. Example, Fahrenheit temperature scale. 0 Fahrenheit is colder than 5 Fahrenheit. Ratio data, similar to interval data but has an absolute zero and multiples are meaningful. Example, election vote, age of student enrolled in statistics. Data collection and presentation. Two types of data, primary data and secondary data. Primary data is the data collected directly by researcher himself. These are the first-hand or original sources. Secondary data which were used by a researcher or any person lifted from other sources. The data gathered are summarized and presented in different forms. Textual form. The data are incorporated in the text of the report. Tabular form. The data are presented in rows and columns. Graphical form. The data are presented in graphics form for an easy-to-digest information. Raw data. Data collected in an investigation and they are not organized systematically. Methods of organizing the raw data. Array. Ordering of the observation from smallest to largest or vice versa. It has advantages because the low and high values can be readily perceived. The process is tedious, especially if the raw data are numerous. Example, a nationwide travel agency offers special rates for package tours during summer. To economize spending for the advertisement, only certain age group of people will be sent brochures. Only those age groups with least people are sent brochures. The following are the age of the previous customers: 59, 50, 52, 38, 80, 62, 77, 56, 60, 61, 58, 62, 51, 36, 54, 18, 71, 54, 44, 52, 26, 63, 58, 56, 41, 34, 61, 50, 60, 53, 62, 62, 53, 43, 63, 71, 65, 79, 45, 66. An array from largest to smallest. You just have to arrange this from the largest to the smallest. So the largest number is 80 and the smallest number is 18. Class 8, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 80, 89. Tally 1, 1, 3, 4, 13, 13, 4, 1. Total is 40. Frequency 1, 1, 3, 4, 13, 13, 4, 1. Total is 40. Relative frequency 0.025, 0.25, 0.100, 0.325, 0.325, 0.100, 0.025. Total is 1.000. Percentage 2.5%, 2.5%, 7.5%, 10%, 32.5%, 32.5%, 10%, 2.5%. Total is 100%. Para makuha mo ang tali, tingnan mo yung array from largest to smallest. Bilangin mo kung ilan ang 10 to 19 hanggang sa 80 to 89. After mo makuha ang tali, bibilangin mo kung ilan yon. So the total tally is 40. Sa frequency naman, bibilangin mo lang yung nasa tally. Pareho sila ng total. Para naman makompute mo ang relative frequency, kailangan mo lang i-divide ang 1 sa 40. So it will be 0.025 and so on. To compute the percentages, you just have to multiply the result of relative frequency into 100 so you can compute the percentage. Fruit and Simon suggested the formula in deciding the number of classes. Suggested class interval equals highest observed value minus lowest observed value divided by number of classes. Suggested class interval highest observed value minus lowest observed value divided by 1 plus 3.322 log n. Class interval equals 80 minus 18 divided by 1 plus 3.322 log 40 is equal to 9.8 or approximately Zeiss. The value of 1 plus 3.322 log n is called the Sloven's formula. Graphical representation of frequency distribution. Graphical forms often more helpful in making a stronger visual impact. 3 charts that will help portray a frequency distribution graphically are the histogram, the frequency polygon, and the cumulative frequency polygon. Histogram. It is a graphic representation of a frequency distribution where adjoining vertical rectangles are drawn on the horizontal axis with the centers of the bases located at the class mark. It is also called a frequency histogram when frequencies are plotted along the vertical against the class boundaries. Frequency polygon is a closed figure of n sides constructed by plotting the class marks against the frequencies. In constructing a frequency polygon, class marks before the lowest and after the highest class marks are drawn in order to close the polygon. Pie chart. A circle that is divided into sectors pie-shaped pieces which are proportional in size to the corresponding frequencies or percentage of frequencies. Measures of central tendency. The most commonly measures of central tendency are the mean, median, and mode. Mean. The most popular and useful measure of central tendency is the arithmetic mean, which simply referred to as the mean, widely referred to in everyday usage as the average. Mean is equal to sum of x sub I divided by n, where n is the total number of measurements, mean is represent the mean, x sub I represents the individual scores. This symbol is a Greek letter sigma, which means the sum of. In plain language, the arithmetic is obtained merely by adding the individual scores and dividing the sum by the number of scores. Example, the grades of Jake in 5 subjects are 85, 86, 88, 90, and 92. What is his mean grade? Solution. Mean is equal to 85 plus 86 plus 88 plus 90 plus 92 divided by 5. Therefore, the average grade of Jake in his 5 subjects is 82.2. Median. The median is the value of the middle item is an ordered arrangement of data. The median is a positional measure, hence the values of the individual items in a distribution do not affect the median. Mode. The mode is the simplest measure of central tendency. A distribution with only one mode is said to be unimodal, while a distribution with 2 or more modes is described as multimodal. Measures of relative position. Quartiles divide the distribution in 4 equal parts. Q sub 1, Q sub 2, Q sub 3. Deciles divide the distribution in 10 equal parts. D sub 1 minus D sub 9. Percentiles divide the distribution in 100 equal parts. P sub 1 minus P sub 99. Used to express the position of a certain value with respect to other values in a data set arranged by rank. A value x is called the 5th percentile of a data set. Provide p% of the data values are less than x. Normal distribution. Properties of a normal distribution. The distribution curve is a bell shape. A curve is symmetrical about its center. The mean, median, and mode coincide at the center. The tails of the curve flatten out indefinitely along the horizontal axis, but never touch it. The curve is asymptotic to the baseline. The area under the curve is 1, thus it represents the probability or proportion of the percentage associated with specific sets of measurements values. Empirical rule for a normal distribution. In a normal distributions, approximately 68% of the data lie within one standard deviation of the mean. 95% of the data lie within 2 standard deviation of the mean. 99.7% of the data lie within 3 standard deviation of the mean. Scatter plot. A scatter plot is a graph of ordered pair x and y of numbers consisting of the independent variable x and the dependent variable y. The independent variable is the variable that can be controlled or manipulated. The dependent variable is the variable that cannot be controlled or manipulated. The independent variable is plotted on the horizontal axis and the dependent variable on the vertical axis. The purpose of this graph is to determine the nature of the relationship between the variables. The relationship may be positive linear, negative linear, curvilinear, or no discernible relationship. Linear regression analysis. Linear regression is the simplest and commonly used statistical measure for prediction studies. It is concerned with finding an equation that uses the known values of one or more variables, called the independent or predictor variables, to estimate the unknown value of quantitative variable called the dependent or criterion. It is a prediction when variable y is dependent on the second variable x based on the regression equations of a given set of data. After a scatter plot is constructed and the value of correlation coefficient is deemed to be significant, then an equation of the regression line is determined. Measures of dispersion. Range. A set of data values is the difference between the greatest data value and the least data value. Range equals highest value minus lowest value. Standard deviation. A set of numerical data makes use of the individual amount that each value deviates from the mean. These deviations are represented by x minus mean. Variance. Simply the square of the standard deviation. For population, these are the formula. For the sample, this is the formula also.